All right, here's my video guide for lesson 923. And it's day 2 of constructions. Yesterday we investigated perpendicular bisectors and rhombuses, and how those diagonal rhombuses are perpendicular bisectors. We're going to build off that today. We're going to be constructing parallel lines. We have constructing a square, constructing a 30, 60, 90 triangle, and constructing a kite. All right. I know that these can get long, but what I want to say before I get going here today is there's a ton of different ways to do these, and so I could make this video as long as I want because I could show a bunch of different strategies. I'm just going to show the strategies that I'm using, but just because I'm using it, maybe you want to try to find another one. That would be awesome if you can find other strategies than what I'm doing here. All right, let's get into the first one though, so we can try to see if we can get this done pretty quickly, now that we know like the tools and everything we need. Okay, so the first one, I'm going to kind of skip through the intro here and just look at the constructing parallel lines. Okay, in this chapter we've used geometric concepts such as triangle congruence and special properties of a rhombus to create constructions, and now we're going to look at, well, how do we construct parallel lines? Okay, so it's saying first, A, examine the diagram at the right. If L, line L, is parallel to line M, what do we know about A and B? And what do we know about A and C? Okay, and so I'm going to type these answers out. I'm going to type some of them, and like the other video, I'm going to work back and forth, flipping between this, the E tool, and the resource page. All right, I'm going to go down here, and for A, what do I know about A and B and, what do I know about A and B and A and C? Well, I know that A and B are congruent because they are alternate interior angles, and I know that A and C are congruent because they are corresponding angles. And so that's how I'm going to write it. I'll say that angle A and angle B are congruent by alternate interior. And angle A and angle C are congruent through corresponding angles. Okay, and that's one thing we know, and that's kind of what we did one time when we were doing those written statements. If lines are parallel, if we have parallel lines, then alternate interior angles are congruent and corresponding angles are congruent. And it goes the other way too. If your alternate interior angles are congruent or your corresponding angles are congruent, that must mean those lines are parallel. And we're going to use that idea to do this construction of parallel lines. All right, and so it says to go to the resource page, and it'll show us this picture right here. So I'm going to bring that up. I go on here. I already have my Desmos eTool open. It's right here. And I click on this resource page in the ebook. And that resource page looks like this, and it says construct a line parallel to L, so parallel to this line L, that goes through point P by first constructing a transversal through point P that intersects line L. So really what that means is this is what we have. We have a line here, line L, and a point P. We need a transversal that cuts that. Pretty much it has to go from point P and it has to cut through your line down here. All right? And it doesn't matter how it cuts, it just has to cut through it here. So I'll cut it like this. All right, now I'm going to use this idea of alternate interior angles to construct a parallel line to this line L right here. All right, the first thing I'm going to do is I'm going to look at, well, what is this angle right here? So I click on this line, I click here, and that's a 97-degree angle. All right, so I'm going to create another line that goes through point P. And the alternate interior angle should hopefully be 97 degrees, and if it's not, that's what we need to change. And so we already have it. I already have it that it's 97 degrees, which means that these lines, this line here and this line here, must be parallel to one another. All right? If it was up at like 106 degrees, that's not parallel because the alternate interior angles aren't the same. If it's down here at 87, that's not parallel because the alternate interior angles aren't the same. The only place they're the same is at 97, and that's how we know that they're parallel. All right, And so right here, I have my parallel lines, L, and another one that passes through point P, and I know they're parallel because their alternate interior angles are the same. All right, we'll keep moving here. Constructing it was part B. Part C then says, if you have not already done so, explain how you know explain how you know those were parallel through alternate interior angles or corresponding angles. And so just quickly, I'm going to say for C, these lines are parallel because alternate interior angles are the same. Or are congruent, I should say. These are parallel lines because alternate interior angles are congruent. Okay, and that's A and that's C, and B was the construction. Okay, we're going to move on to the next question already. And this one is the construction of the square. All right. How are we going to construct a square? I actually sat and really worked on this, and there's a ton of different ways to do it. But let's first answer question A before we get into the actual construction. It says, well, what makes a square a square? Otherwise, what are its unique characteristics? All right, and the unique characteristics of a square are very unique, actually. No other shape has them. A square has all equal sides. It has two pairs of parallel sides. I can't spell parallel. There we go. Parallel sides. And it has 4 90-degree angles. Those right there, if it meets all those properties, we definitely have a square. It's the only shape that has these qualities. All right, and so that's what we're going to try to build here. We're going to try to build a shape that has all equal sides, 2 pairs of parallel sides, and it has 4 90-degree angles. Okay, so I'm going to go to open up the ebook. I already have my e-tool ready to go, so I don't have to click on that again. And then you can open up this resource page, and it gives you, it just says develop a strategy for constructing a square. All right, so they leave it very open-ended. Now, I'm just going to say quickly, this is not what I want you to do. I don't want you to go onto the e-tool and make a segment and say that this is, you can click on it and say that length is, well, that length is 2.78, and then try to make another segment here that's 2.78. I don't want you to try to construct it this way. That's not how we construct here in geometry. And say, so what we're going to do, instead of just trying to put lines together and say that that looks 90, we're actually going to construct this so we know we have 90-degree angles and we know that all the side lengths are the same. And this is how I go about it. There are multiple ways, but this is how I'll do it. The first thing I'm going to do, and actually there's going to be a lot of ties to the perpendicular bisector that we did yesterday. I'm going to use a straight line, and I'm going to construct the circle from this center out to here, and a circle from this center out to here, meaning that these two circles have the same exact radius. Okay? I'm going to construct the perpendicular bisector we saw yesterday by going from the top intersection down to the bottom intersection, and I know from yesterday that's a 90-degree angle in there. All right? Also, what I know is that this is the midpoint of this line. That point right here is the midpoint of this line. So what I'm going to do now, and this is where things get a little tricky, I'll try to delete circles so you can see it. I'm going to do a circle that goes from my point out here to the midpoint of that line. And I'm going to go from the midpoint of the line out to this circle here. All right. I get a new point up here. And let's actually get rid of this couple circles quickly here. What I can see now is that this distance from this circle I created, this distance is the same as this distance right here. They're both the radius of this circle. All right. So now I have a 90-degree angle and 2 equal distances from using circles. Okay. The next thing I'm going to do is go from this point here back to your midpoint, and from this point here to your midpoint. So now I again have two circles with equal radiuses, and they intersect up here. All right, and so I make my point, and I can connect these points now. I can connect here to here, here to here, here, and here. Now if I get rid of everything I don't need, I'm looking here and it looks like I might have my square. So I'm going to hide this, hide this. Ooh. There we go. And it looks like I might have constructed my square here. All right, to check, let's look at the angles. That's a 90-degree angle. That's a 90-degree angle. Oop, I screwed that one up. Sorry. Here is another 90, and here is another 90. So it's got the 4 90-degree angles in it. It's good to see. And hopefully the side lengths are all the same. And if I click them, 2.23, 2.23, 2.23, and top 2.23. All right. And so I have my square constructed. And again, really, it's just using this idea of circles and radiuses. And if you can use circles and use the same radius over and over, in that idea of perpendicular bisectors, you can create this square. Like I said, there's a bunch of different ways to go about this. I'd like you to try to find another one, but this is a way that does always work to create a square. All right. Now what I'll do is, and what you can do too, there's a different way that you screenshot, but I would screenshot this picture. Screenshot this picture here. And I would put it in my slideshow for answering part B here. Actually, really, I'm answering part B and C. I'll read C, but it's really answering both of them. Part B, and then I can paste my picture in here for part B. Okay. And then part C, all it's saying is, in order for your shape to really be a square, it must have 4 right angles and 4 congruent sides. And so, I mean, I made it in part B, and I also did prove in that part B as well that I had 4 90-degree angles and 4 congruent sides, so that picture works for part B and for part C. Okay? I will move on to the next problem here, and we have this one. We are going to construct a 30, 60, 90 triangle. I only have 2 minutes left in this video, so I'm going to finish up this problem and the next one in a short second video.